shows the full dream team. It was a mix of two groups. First, the ex-Motorola engineers, and include Chuck Peddle, the architect, and Bill Mesh, the logic genius. They bought the version, but they need help to actually build the chip. That was the MOS experts came in. People like Rod Ogrill and Harry Burcom. They were expert to lay out the manufacturing. Rod Ogrill, for example, designed the silicon technology, and Terry Holt makes sure that the production actually works. Without this mix of system architects and manufacturing experts, the 24 prize would have been impossible. So September 1975, San Francisco Westcom. This was the official launch. MOS technology did something crazy. Remember, Intel and Motorola sold their chips for over $200. MOS put up at that said $25. People thought it was a joke or a scam. They said a working CPU with 25 bucks, that's impossible. These must be rejected. But MOS and a big glass jar full of chips, Chuck Peddle and his team stood there and sold them directly to the engineers. They accept cash. 2 $20 bills. Here is a change. Here is your CPU. But the end of the show, they had sold all of their chips, and the industry was never same again. I have to tell you a funny secret about the show. MOS wanted to look like a big successful company, so they put big glasses jars on the table, fill it to the top with chips. It looked impressive. But Chuck Peddle later admitted it was a trick. The jars were filled with broken chips at the bottom. Only the top layer worked. When people start buying them with cash, the team panicked. They had to dig through the jars to find the good chips fast enough. The idea behind this 64.1 was aggressive. It's a version before the 260, sorry, the 60-1. It was designed as so-called drop-in replacement. It was, you could take a Motorola 6800 out of its socket and drop the 6401 right in, same pins, similar commands, but much cheaper. Motorola layers saw this, said, no way, that is not close. They forced MOS to stop selling the 6501 immediately. It was on the market for only a very short time. We look at the raw performance of the 6402. Wins easily against the 6800. Even at the same megahertz speed, the 6002 is about twice as faster. After the CPU was ready, MOS needed a way to show into the world. So in 1976, they released the KIM-1 computer. KIM-1 stands for Keyboard Input Monitor. Then come the Apple I and the Apple II and consoles. It wasn't just computers. This 6502 also conquered the living room. Looks at Atari 2600 to save money, and they used stripped-down versions called the 62.7. Here's the Atari 400 and 800. Fun. The architect from Atari built later the Amiga. And here, in the 80s, Commodore ruled the world. He started with the VIC-20 in 1980 and was cheap, friendly, and it still used the original 6502. But then came the big one, the Commodore 64. For the 64, MOS technology updated the CPU. They called 6410. It was basically a 6402, but he had special trick. He could manage more memory. And Apple starts with his Apple IIc. And this one is the first 60-bit computer from Apple, and the last version with a 6502 based CPU. The rise and the fall of MOS technology. So what happened to the company MOS technology itself? After the lawsuit with Motorola, MOS had a great product, but no money left. In 1976, Commodore bought the company. This was a genius move. Suddenly, Commodore owned the factory that made their CPUs. That's changed the name to the Commodore Semiconductor Group, or CSG. If you open a C64 today, you often see CSG on the chips. That is MOS technology. The legend today. Now, you might think the story of the 6502 ended with Commodore went bankrupt. But you are wrong. The 6502 found a new life. In toys, do you remember Furby? That's a little Furby robot from 1998 that talked and blinked. They sold 40 million of them in just 3 years. And inside every single Furby was a chip made by Sun Plus. And guess that's architecture that chip used. Yes, it was a 6502. So we talk about Furbies, but this is the most amazing part of the story. This 6502 is not just a toy. It saves life. Even today, the architecture is used in medical devices, including pacemakers and implantable defibrillators. You might ask, why would doctor put a 50 years old chip inside a human heart? The answer is trust. Modern processors are complex. They have bugs, glitches, and overhead. But the 6502 is simple. We know everything about it. Was being tested for decades and does not crash. It does not do accepting things. When you build a machine that must not fail, you don't want the newest chip. You want the most robust one. And that is why the 64 is still beating in people's cheese today. I want to show one of my favorite celebrity users of the 6502. It's Bender from Futurama. In the episode Fry and the Slum Factory, the professor looks inside Bender's head with X-ray. And and if you pause the video at exactly the right moment, you can see it clearly. Bender's brain is a 6502. We saw Bender, but there is an everyone more dangerous robot running on a 6502, the Terminator. In the 1984 movie, whenever we see the eyes of the T800, there is code scrolling on the screen. If look closely, you will see instructions like LDR, STR, and jump. Yes, the Terminator runs on 6502 assembly. This gets better. This is not Skynet Advanced AI code. The filmmakers just grabbed a magazine called Nibble, which was for Apple II hobbyists, and copied the code from there. Now, you might think the 6502 is just an accident history, but its spirit is very much alive today. In the early 80s, the British company called Archon Computers wanted to build a new powerful machine. The lead designers Sophie Wilson and Steve Ferber looked at the processors from Intel Motorola, but they hated them. They found too complex, too power-hungry, and too clunky. They loved the 6502. They loved how simple and elegant it was. So Sophie Wilson decided to design her own processor. She looked the philosophy and the 6502 simply and low power, and scaled up to the result was the ARM processor. We talk about we have talked a lot about history today, about the past, but for me the 6502 is not something that belongs in a museum. It belongs in your hands. In 2024, the legendary chip celebrates the 5th anniversary. I didn't want to let me milestone pass quietly, so I decided to build something. I present you the CMOS 6102 50th anniversary computer badge. This is not a piece with some blinking LED. It's a fully functional single board computer. It's a love letter from the engineering of the 1974, but built with modern tools. It's allowed to carry the spirit of the Apple I and the Commodore 64 right here around a neck. It shows that 50 years later, the architecture is still fun and still education and still beautiful. In this year, this legendary chip celebrates his 50th birthday, and as a fan and engineer, I did just want to bake a cake. It wanted to build something, so I started a project to honor this milestone. I presented you the MOS 6402 50th anniversary computer badge. It's not just a piece of blinking LEDs, it's a fully functioning computer. And here started my computer. Yes. This is my badge. I switch. Yep. And this computer is this one. Has 32 kilobytes RAM and ROM. Has a SRAM buffer battery, and you can use accumulatoren for powering up, and you can use and use USB-C connector to connect to your PC and program this 6502 computer. I can show you. Moment. This is PuTTY. So. And this connection is a serial connection, and you can write some commands. Here's your help screen. You can go to a basic interpreter and run basic programs. Oops. Or you can has an assembly disassembler and assembler on board, and you can control the 7-segment display and 7 LEDs. Beispiel, example. Hello world. Oh, now, hello world. Yes, that was it.
Oh. Hey, thanks, Frank. Is it time for questions now? Time for question? I don't know if there are anybody with questions in the. Maybe I can start with one. I asked you already just before we started the event, but you told me this basic interpreter, so it's something similar to OpenCBM. So that means it's compatible with some Commodore Basic, but with which one is it compatible?
Yes, this is a enhanced Basic. It's a special version for the 6502 processor. It's programmed by this guy here, Lee Hart and Derry Richter. And this is a simple basic interpreter you can implement in your own 6502 project. And I do this. I put this in this ROM, and it's running.
Okay, perfect. Yeah. It doesn't have the same memory map as the, for example, the Commodore 64 or something, right? I cannot poke some specific addresses the same as.
I have documented all these things on my moment. You can buy, can download here, downloads, and see what. So, and you have all manuals, and my manual to this computer is here. Check. And here I have, oops, a nice manual for all details to build this computer. You can order the PCB on PCBWay, and oops, and have fun.
Okay, nice.
Yep.
Any other questions from the attendees? If not, I think worst case you can always put it in the chat. I would say many thanks, Frank. I will stop the recording now. And then I think we can call the next speaker, who is Laurent, to start sharing your screen. Unmute yourself.
Hello.
Hello. I can hear you. Yeah, you just need to share your screen. Yes, perfect.
Oh,
Give me
go.
1 second, I will start the recording.
Okay.
There you are. It's your turn, Laurent.
Can I start?
Yes.
Oh, thank you. Hi, everyone. I'm Laurent from Hungary, and I'm going to show you my recently released C64 emulator software and to tell you a little bit about its backstory. The history of my emulator dates back to 1997. That was when I decided to write a seed emulator that would first be able to run programs written to the C64. At the time, I was programming in Turbo Pascal and x86 assembly. So the project started in Pascal using a bunch of inline assembly code. At first, it had nothing to do with the SID, but at least most of the programs ran. Based on the data written to the SID register addresses, the PC speaker played sounds similar to those of early DOS games. By 2001, I had developed envelope generators, waveform generators, and a very basic filter. And all of this was played back on a Sound Blaster sound card with an 8-bit mixer. There were no serious measurements behind it all. I implemented everything because based on the data described in the reference books, supplemented with my own ideas. For example, the combined waveforms were mixed with logical AND operations, which, as it turned out later, is not how it actually works. I had never heard of state variable filters before, so I tried to simulate the seed filter using fast Fourier transformation. There was a visualizer view showing a linear spectrum analyzer and the volume envelope status of the 3 channels. By 2005, I had developed a C64 emulator written entirely in assembly language, which handled only one filers and seed files, but has no longer limited to play music, as it also emulated the VIC-2, more or less, allowing it to be used to play some simple games. Its unique feature was that it created a 400 times 276 resolution video mode at 50 Hertz by uniquely modifying the registers of the VGA card's cathode ray tube controller. After a 15-year break, in 2020, I was inspired to revive my old C64 project, now with OpenGL graphics, 16-bit sound, and C++ code. I was working on a synthesis-based MIDI player at the time, so I know a lot more about sound physics and filter algorithms. Of course, I was interested in how the entire C64 works, but I always most interested in the SID. So instead of focusing on floppy drive emulation, I concentrated on learning as much as possible about the SID. I created a special view where I could compare the current sound output of my emulation with the sound output of the C64 connected to the sound card's line input, and wrote a small basic test program. Sorry. That I ran simultaneously under the emulator and on the connected C64, which gave me an accurate overview of the differences in real time. When I began to find the quality of the SID emulation acceptable, my interest began to move towards electronics. As a result, in 2021, I made my first SID replacement prototype board, the SIDEMU board, which was based on an ARM Cortex M3 microcontroller. I planned to turn it into a product, so I created an Android-based SID player app to showcase its capabilities, which runs exactly the same code as the board. But it soon turned out that in modern demo music, new tricks are being used more and more often, which based on reading back of the actual values of the oscillator and the envelope generators of the third channel in real time. To solve this problem, I came up with the idea of placing two microcontrollers on the board, one of which would be dedicated to serving the readouts of the two registers, while the other would do everything else. This means that two different SID emulations would run in parallel at the same time, but they will act like one precise SID. And here's the final result with two ARM Cortex M4 microcontrollers. It now had a digital analog converter as output instead of pulse width modulation, real-time readback capability, and up to two external buttons can be connected to it, which can be used to switch between 8 different SID templates on the fly. R2, R3, R4, R4AR, R5, and the three custom settings, which can be edited using configuration program that runs on the C64 itself. Since 2020, seed filter emulation has been almost completely redesigned, coming very close to real seeds. And the emulator has also continued to improve as well. While it's still primarily serving to uncover the filter secrets of the seed, I have developed the emulator to the point where it may be useful to others as well. So this year, I made it available for anyone to download it. On the following pages, I have summarized some of the features of the emulator, such as the improved filter algorithm, improved VIC2 emulation, some performance improvements, the CRT emulation, video frame rate interpolation for smooth scrolling, even if your monitor's refresh rate doesn't match with the 50 Hertz. It is a closer look at the CRT emulation, which is basically a special shadow mask texture combined with the output of the VIC2. The supported file formats are program files, disk and tape images, cartridge files, seed music files. Unfortunately, there is no real floppy drive emulation yet, but many games are also available in Easy Flash cartridge form. Many people have asked how this emulator differs from the others, and what is the point of yet another emulator. First of all, I made it because I want to understand every detail of the C64 in my own way. I didn't want to write a better emulator, but when I felt that something wasn't good enough, I always tried to find a better solution for my actual problem. Here are some features I'm proud of. The CD emulation, especially the 6581 filters, the integrated seed player, the CRT emulation, and the debugger. You can listen to seed tunes directly from the emulator, but you can also listen to seed music in random order. All you have to do is specify the high voltage seed collection path in the config file. You can choose from several types of visualizers, such as scope, spectrum analyzer, or binaural-like view. You can debug your programs or learn from other people's code. You can set breakpoints, view the memory map as hex dump, PETSCII, screen codes, or even as assembly code. You can also view unmapped memory areas, even cartridge banks. It's connected, obviously. Here you can see a list of tunes to listen to, so you can compare them with other emulations or with real seeds as well. You can listen to real R4 seed recordings on Stone Oak Valley's website. The R4 I implemented is most similar to the R4. He used for his high voltage seed collection 49 recordings. You can read more about the emulator on my blog. And from time to time, I post videos about my work on my YouTube channel. The emulator itself can be downloaded from the blog, but it's also available on CSDB, and the CDEMU for Android can be found on Google Play. It's a free app. Thanks for watching, and many thanks to Sebastian for the invitation. Since I'm not very good at real-time conversations, please ask any questions you may have in the chat. Thank you.
Many thanks to you, Laurent. I will just ask you to put in the chat maybe as well if there is some links to the SID replacement board and to the SID emulator for Android. If you can also put the links in the chat, maybe. Yeah. Many thanks. I will stop the recording and then questions go to chat. Many thanks again.
Thank you.
And I see actually that there is a couple of questions already for you, Laurent, in the chat. So you can start typing the answer. In the meantime, I will ask Marcin to start sharing his screen. And to unmute as well.
All right. Can you hear me? Well,
yes, I can hear you. Perfect.
Okay, let me share the screen. So at least my presentation hopefully will be short, and I can show a demo in the same time. Okay. Can you see my screen? Which is put on the full screen.
I can see your screen. Yes.
Right. Okay, so should I start?
Just 1 second. Let me start also the recording. I see your turn, Marcin. Thank you.
Okay, no worries. So hi, my name is Marcin Spoczynski. So by profession, I'm kind of a researcher, so mostly around the chips and machine learning. But I'm also involved, just like in retro computing for many years. Especially, my love is Amiga and the computers, Commodore systems. And I'm Amiga guy from the time I get my A600 for my 11th birthday. Previously I used to have like a C64, but it was 64 was mostly used like a gaming machine for me at this time. And Amiga was like the first computer which I used actually for some kind of the programming. You can't really name it programming at this time. It was like mostly writing, whatever I find, just like in the magazine at this time, and and so on. And so let me just quickly say, just like about the project, just like it's what I really wanted, just like when I get my like Ultimate 64 or Ultimate 2, many times when they're just like doing some work, I really love, just like listening to the seat and so on. But, my dead space, just like I had boundaries. So, just like for me, it was always, just like, can I actually, just like, listen to those seats remotely? And on the other side, I like to be like, just use the hardware as much as I can, not really using much of emulation. Even I know that's, just like today, the emulation is the one of the best and so on. So what I will say, just like also about me before I wrote actually, just like the seed player and a couple of those Ultimate 64 tools, I wrote a couple of others, but small software like a Tune Finder, which is like a radio player, and a couple of like the small project which probably you can find on the Eminet or like on GitHub, if that was more recently. Okay, so what is actually, just like the project is like the set of like Amiga OS tools where you can actually control real C64 hardware or emulated in FPGA, hardware when you look at the Ultimate 64. Oh, sorry, I just accidentally pressed then. So as I said, just like this is like the set of the different like just like Amiga OS applications. Mostly what you really have like you can use them on Ultimate 64, and then just like also Ultimate 2 as a form of the cartridge. And of course, in the future, when we get like the Commodore 64, which is already produced, you can use just like those tools out of the box, to control your Commodore 64 Ultimate, because we know that's actually it's like a Gideon project, just packed in a much more sophisticated case, and so on. So idea was like as I mentioned before, like just like don't use the PC, don't use anything, no browser, because as some of like Ultimate 64 can be easily controlled through the web browser. However, just like the set of the web browser capabilities are rather small. And I also didn't want, just like do like any emulation or like, just like application, develop the application for PC, at least for this time. Okay, maybe I just jump a little bit in the front. So the first application actually, just like, which is the part of the set of the tools, is like a U64 SID player. And I think at least for me, it's like the most fun part. Just like it's mostly dedicated 6 music player, and there you can use like a real SID chips from your Ultimate 64 or C64 controlled by the cartridge. And so especially as for me, since just like the Amiga can't play from the SID chips except for some of the Zorro cards. Just like the controlling, the real SID chips is really fun. So what it does, just like it has like the ability to just load your local SID chips and just simply play them. But additionally to that, you can also use just like a HVSC something. So in this way, just like your player will be able to actually understand the length of the SID tunes, and also just like it's able just like to figure out what kind of the chips that actually you have on your Ultimate 64, and just like do some random things like probably most of the players will do, if you can imagine, like just like skipping over the tracks, look over just like find the tracks, clip playlist, and also have like a full functionality of the playlist itself, so you can save your favorite tunes, and so on. So it does not require just like a much more from Amiga. It can run on any 6800, even just like so you can run it probably on and even just like entry-level Amiga. However, to use like the sound length, just like from HVSC, you require much more just like a much more sophisticated hardware, because that's involved like the hashing of the file and understanding the the length of the file, and then correlate some of those the values just like in the software, which is CPU heavy for Motorola chips and for other chips in this era, and so on. So as I mentioned, just like it has like a playlist. You can play the sub song also because I think this is the one just like of the my favorite band. You can do the shuffle repeat. It is able to actually figure out that it's like a dual seat in the case of the songs, and it's integrated with the HVSC database and so on. Second part is like for people who love the command lines, just like it's just like a set of the tools, which is where I started, because just like some of the I started writing just library in a C, just like to have ability. So my first, just like a touch to control the Ultimate 64, it was like through the CAR library, but also just like it creates more ultimate tool when you actually can use like some scripting language to really automate, just like the controlling of your Ultimate 64 cartridge or the board, where you can actually just like do the much more things when compares to the music player, like mounting a disk, just like around your PRG, CRT loading, pick into the memory, pop, write, and also, just like the control machine. So like a reset, reboot, power, or even, change the settings on fly when your Ultimate 64 in a cartridge form or whatsoever, it's online. It will also discover what kind of the what kind of the hardware you have and what kind of the set of the control you can control in the same time. And the last one, which is like Ultimate 64 GUI, which is really mostly the same thing that you see before in the control, but in the form of the GUI. So I use like the MUI, which is like a user interface for the Amiga to just develop the application. So it mostly have like the same set of the functionalities like the command line one, additional to the ability to actually play music. And we know that's actually the Ultimate 64 and the cartridge. You can also play Amiga tunes, like mod files up to the 4 tracks. And you can also, just like use this app as a keyboard input. So you can even write your program when you are away from the keyboard, from the Commodore keyboard, and so on. So as I mentioned, so native application. So you have like the management of the disk and cartridge, memory tools, and keyboard input. So you can look when you're actually writing given the code in your Amiga, and you have like the Amiga mode playback plus, of course, the seed. But this is like much less sophisticated part because you can only like load one seed in this phase. So as I mentioned, just like what I use is like a out of the box Amiga 6.x application, and you can run it. We tested it actually just like on the many forums. So it's working on the LS4, which is on all of the Morphos, which is like a Amiga API implementation very well. It's just required TCP/IP connection, which is given from the cartridge or through the LAN or VLAN. And you can also, this is one of the things, you can also use the many endpoints. So you can control the many different Ultimate 64s if you have. So this is the idea that I can say later. There is also already built the branch when if you have like a 2 Ultimate 64 with different sets of the SID chips, you can actually, based on this application, steer the specific tune to the specific required SID chip. So for example, if you're, just like if your app require 8520, so then it will be, just like automatically steer, this sent to the Commodore, which has those chips in there. So you can then, just like have at least, idea, just like how the specific SID sound in the end. So that is like a very, experimental. I didn't have like much time actually recently to close this fully feature, but it's working, and I plan, just like to, work in a stable version, and so on. Okay. So in the end, you have like the really Amiga, which is mostly old school hardware, to control the 64, and it's working with any classic Amiga system at this moment, and just like and you can use it even today or anywhere, and it's available as a source form and also just like as a compiled binary for any Amiga OS today. Okay, so we get into the live demo. So I will have to switch the camera. Probably that will be the easiest way. And actually, I will have to actually switch the input of the monitor. So I hope we will stay all the time. So let me actually, oh, sorry. How to get, okay, I get out of it. And let me just switch camera to my iPhone. Okay, we have a Zoom. Show the grid. Just I try to see the. Should I stop presenting? I forgot how to do it. This is full screen and how to see. This is a grid.
You're still sharing for the time being.
Oh yeah, that's great. Actually, just like I want to
Okay.
keep sharing because I have to just. Okay, actually, I just can stop sharing. I believe. Share. Oh no, I think okay. Stop share, and let me turn on the video. Switch to the. Okay, I'm here. I hope that it will. Why
A bit
it's
blurry
so
at the
blurry?
moment.
Okay, I know what I did.
Okay.
So let me just unblur it. Okay, I think you can see here. So let me just switch my Amiga. Okay. You have to tell me if you see anything. Is that enough?
I guess so. Yes, we can see the screen and the top of the Amiga.
Righty. Okay, so let me right now run the app. So maybe you can start with the SID player. So even of my 60 Amiga, it takes a while to actually load for the first time database. And you can see here, like the amount of the mouse is quite high. And what I have to do is just load all of the files, not all of them in memory, but at least in a cache to have ability to parse the database. So it has like 100,000 entries. So
We
it
don't see
takes a
the full
while.
screen, by the way. I'm sorry. Yes, this is better.
Okay. Okay, thank you so much. Here, on the other side, you have like my Commodore is actually, playing AC/DC pinball at this moment. Okay, we have like the sound flag. Okay, we have it ready. So what we have to do is just like do the connect, and we have connected. So the Ultimate 64, it just understood that he has like a 6581 two chips. They are on the two different addresses, and whatever we have to do is just like add the new files. So let's us just like the load couple, and you can see here, just like the player automatically see, if that's like if the song contains like a sub song in this case, or just like and also will parse the length of the songs. If you click, of course, it will automatically just like at the start playing on the Ultimate 64 SID players. And it will continue playing until he will reach like the sub song or the next song and so on. And of course, just like the basic things that you can do, like it's a search, or add new files, or just like just simply skip the sub song because just like I don't really like it. in this way, and so on. You can also, just like as I mentioned before, you can do like a save and load, just like the playlist if we like it, or just like just stop listening of it. It will also automatically find out if there is a new database of the songs of the HVSC site, and yeah, and I think that's all really from the functionalities, as it's quite a simple one. We can also skip, just like go to the the control side, and let's connect to our Ultimate 64. So what we can do, we can just like maybe run one of the PRG files, and in this case, it will be, let's try like ACID 2000, and you can see that's like instantly it's loading it on the on an Ultimate 64. And what you can do, you can just press play and you're ready to do it. So you don't have to keep everything on your USB stick drive. You can do it, just like directly from Amiga. Of course, just like some of the things that you can do, like it's, just like mount this drive and so on. Of course, you can also reboot machine remotely, you press the menu, or like just like a reset power off. You can also pick into the memory, or you can, for example, write something on your Amiga and send it back to the Commodore. It will automatically translate from regular Amiga input to the Commodore. So here, like I can write something simple. I can just like the type some of the commands and ultimately run on the 64 Ultimate or whichever cartridge or C64 you have. Okay, so let me switch back to the presentation. And okay, now let me switch the camera. Okay. Oh, can you see? Let me just share whatever we had before. Yeah. So as you see, just like there are a couple of tools, that you can use it. You can download it from GitHub or from the Aminet, and it's over there. You can control your real 64 or whichever Ultimate the computer that you have, and it's a fun way, just like to play around. Also, some time ago, I just wrote the GUI application that you can also control from a PC. It's not really maintained much, just like but basic functionality are still there, and just like if anyone have like this Ultimate 64, I have a plan to actually release the iPhone and Android app probably very quickly. It's already written, just like to be honest, I didn't have like a much more time to really fully tested it. So it's another way to actually control your Ultimate 64 in the future, and it has like all of the functionalities actually that were implemented in the all those set of the Amiga apps, plus just like a number of additional one, like just like a full control of the settings, or like even the streaming of the video for Ultimate 64 in the VGA form. Okay, I think that's all. I thought that would be much shorter. If there are any questions, I'm happy to answer them. And thanks for invitation.
You're more than welcome. Let's see if there are any questions from the attendees. Otherwise, in the meantime, I have at least a couple. So you're using TCP/IP. I guess you're buffering some certain part of the data. How in practice do you do that, and trying not to overload also the memory?
Oh yeah. Okay. So for Amiga, we just you can slice very easily, just like the data that you send, so you don't have to send it in a one file. So mostly what you have to do is just like send just only the fragments, just like you can packetize in a TCP/IP form, which is well supported on all of the actually Amiga system. It's actually very well working with the microcontroller, which is on the Ultimate 64, because if you will try to send much more data, the Ultimate 64 will die in the same time. Just like, and it's really hard to recover the cache. This is what I feel. Even the one reset, just like won't work. So, just like it was a couple of different tries. What kind of the lack of the packet, just like. Ultimate 64 works well because if you want to send a longest file, it will take a while, and it's really easy to just to kill Ultimate 64, and it stopped become responsive. What I find out actually, it will, in my cases, for the first just like I try and fail scenario, the Ultimate 64 card just stopped working. And just like it gets back after a couple of minutes after reset. But probably just like the still memory something was in a memory.
Okay, thank you. I don't see other question. Anybody? Any questions? Otherwise, I will just thank you again, Martin. I will stop the recording.
Thank you so much.
And then if in the meantime someone has questions, they can still post them into the chat. Then I will ask Daniel to get prepared, starting sharing maybe his screen.
Yeah, I'm ready. So we're going to do a live demo, so there's no slides.
Oh, okay. Then let me just start the recording again.
Okay.
Your turn, Daniel. Thank you.
All right. So hi, my name is Daniel Landbauer, and I'm here to talk with you about the Econo Pet. This is a project that started when my son was 8 and asked me if we could build our own computer. And after some research, I decided that the Commodore PET was, the simplest architecture that could still run programs that would be, interesting, mostly games. And so that's what we decided on. And so it started as a, just a 6502 on a breadboard. And, my son is now 13. The project's evolved a lot since then. And so this is what it looks like now. It's no longer on a breadboard. It's a PCB. And it fits inside of a Commodore PET or CBM series machine. And it can be used to repair one if the main board's broken, or it can be an upgrade since it emulates it. It can function like the most the latest models of the PET, including the CRTC chip and the 64K expansion that Commodore made for the 8096, which gives you 96K in total. And so it's roughly equivalent to the Commodore Dynamic PET V2 board, if that means anything to you. So with that introduction, I'm going to move on to the demo. And so behind me, I have a CBM 8032. It was one of the later PETs made. It's got a 12-inch monitor, the business style keyboard, and it's 80 columns. And so in my part of the world, PETs are hard to come by. This seems to be the most common in my area, and so this is what I have. But unfortunately, while I love this machine, it's also one of the least compatible software-wise. And so I'm just going to show you a couple of the problems we have. So here I am running Space Invaders. And as you'll see in a minute, this was actually designed for a 40-column PET. And so you see the screen is wrapping around. You get 2 rows per row. And then this is also one of many games that peaks the keyboard matrix directly. And since Commodore changed the keyboard matrix between the normal style pets and the business style, I can use, I think, tab to shoot, delete to move left or right, and then there's no key to move in the opposite direction because it just doesn't map to anything if you have a business keyboard. And so this is a machine that is clearly in the market for one of our EconoPet boards, so we're going to install one. So turn it off. We'll open it up. The pets are a lot of fun to work on because they have this nice clamshell case on a piano hinge. And first, I'm unplugging the power. Don't forget that. And any other accessories in the back. And while we're talking about power, I'm sure everyone knows this, but I'll just mention it. This whole axis is the monitor. The CRT can retain a deadly high voltage charge even when the machine is unplugged. And so don't put fingers in this hole here. So anyways, back to our installation. There's 3 cables to remove. There's the video, keyboard, power, and then normally you'd have to unscrew the board, but I've already done that. But there's some plastic retention clips. There you go. And with that, the board comes out. It's pretty sizable. And I guess another tip, when handling these, you should be taking precautions against static electricity. And so I'm definitely wearing a grounded strap that you can't see off camera. All right. And then here is our EconoPet. So it uses the same 2 back screws that were used on the original board, then 2 nylon standoffs because the board is too short to reach any of the rusted screws that are on the case. And I apologize for what I'm sure is a flattering camera angle while I put this in, but don't worry, it'll be worth it. All right, then we reconnect our cables. So video and the keyboard cables are keyed. You can't put them in the wrong way. There's a missing pin and then one of the holes is plugged. And the same is true for power on the later pets. If you have the 9-pin power model, which I think is the most common. There was also a 5-pin version, which isn't keyed. Instead, it's symmetrical. You can plug it in either way. Just make sure you use the 5 pins here on the right if you have one of those. And we'll plug it back in. And cross fingers, turn it on. All right, that was an encouraging sound. All right, so now I have a real 40-column pet. We'll go back to that Space Invaders program we were trying to play before. And while we have our 40-column display like we were hoping for, we still have a problem with the keyboard. And unfortunately, the EconoPet main board can't rewire the keyboard matrix. But we do have a workaround. So this is a USB keyboard. And on the side of the EconoPet, accessible through the expansion port here on the right, is a USB-C connector. And so I'm going to plug this keyboard in. And the way this works is this keyboard can be either the business keyboard layout or the graphics keyboard. You control that with a num lock. And so when the light is lit, it'll behave like a graphics keyboard. And so I'll finally get to be able to play that game of Space Invaders. I can move left and right. Everything's working properly. And so we're good. Another feature of this keyboard is that the scroll lock key will toggle between symbolic and positional. When it's using a symbolic layout, the keys basically behave like they're labeled. It tries to map a modern keyboard to the PET keyboard matrix as best as possible so you can type naturally. And then positional tries to map it by position. So they do the closest approximation of position on the keyboard to key here in case you have some software where it's important that the key's in the right place. These layouts, I followed what Vice did with the Vice emulator. It has the same set of features that you can configure. So another modern convenience of the EconoPet is that there's a HDMI port. So if I take this HDMI cable, and unfortunately the connector was a little too tall to fit through the expansion slot, so I've got to open it, but I feed the cable through the expansion slot and then plug it here into the connector on the bottom. And we turn this on. We'll see that we don't have just native PET video, but we also have, you're able to use modern displays like this one over here. And if you wanted to, you could take your EconoPet board, connect USB, HDMI, and just a regular 9-volt power pack, wall adapter, and you can use the board standalone. You don't actually have to have a PET to use it. Although I think probably most people will be using these to repair or upgrade their PETs. So another feature is that there is a push button on the side, which is accessible to the side. And so if I reach over here and push it once, or I should say push it briefly, tap it. It works like a reset, so you don't have to power down and power on your machine like you did with the original. And if you hold it, it'll take you to this power on menu. And the power on menu is listing various models of PET that you can configure the board to behave like. And so we have, the 4000 series and 50 and 60 hertz variants, the 8000 series, which are the 80 column ones with 50 and 60 hertz variants. The PET 2001 with upgraded ROMs, or the PET 2001, which is going back to 1977, had the original ROM set with all of their func-works. And so just to show an example, I'll pick an 80 column PET. So now we're back in 80 columns. And so if you have a 40 column or an 80 column PET and would like to use all the software, an EconoPet board is an option. And probably the best app for the 80 column PET that I've found so far is the Infocom interpreter. It's a lot of fun to play Zork in 80 columns, especially with the 96K expansion, because then your entire disk gets cached into memory. And so it's very quick and responsive. Then, since I mentioned it, just for fun, we'll do the 2001 upgraded ROMs, so we can quickly see the famous Microsoft Easter egg. And so there it is. You type wait 6502, 40, and it prints Microsoft 40 times. And so I think we've covered most of the main features. There's also an audio jack on the side for if you want to use amplified speakers instead of the little built-in piezo speaker. A lot of expansion ports that I can answer questions about if people are interested. Most of these were things that I broke out during the design of the board for attaching logic analyzers, but then decided to clean them up and keep them because they could be useful in the future. Exposing all the address data lines, control signals, and so on. I've got one last thing for you, which is on the side of the board, there's a micro SD slot, and what's on this micro SD card is a YAML configuration file, which when the machine powers on, it reads from that the list of different models, what ROMs to load for them, how to configure the hardware, is it 40, 80 columns, and so on. It also has a folder with all the ROM files, and so if you wanted to play Attack of the Petsky Robots using David Murray's custom PET ROM that changes the character graphics, you could do that. You can have the I don't want to say bitmap graphics, but a different appearance, I guess. And the other thing that's on there is the firmware for the machine. And so recently we had a US holiday, and so I had a 4-day weekend to do some hacking. And so I'm taking out the SD card, which has the released firmware that's currently on the site. And I'm putting in another SD card, which has my 4-day weekend project. And I'm going to reset it really quickly in here. And you won't be able to see it, but there's an LED that's blinking really rapidly to let me know the firmware is resetting or reflashing. And when that finishes, we'll come up and we've got a new option called surprise. So I don't know if you've seen anything different yet, but you will in a minute. So a pet with color. So this is a modification which was done by Stephen Gray. So Steve Gray's color pet is a really cool cover project. I don't want to steal his thunder and describe it to you, but over a 4-day weekend, I had a chance to implement it. One other one that you might be interested in is I have an experimental SID chip implemented on the FPGA available at address 8F00. I guess there was at one time like a pet SID card. The Vice emulator emulates it. I only know of one piece of software which uses it, which is the new Pets Allowed demo, which also uses a lot of really complicated CRTC tricks. And that turns out that was the first piece of software my son wanted to run when we got this thing, got the EconoPet first working. And so a lot of my first early year was, was spent trying to implement all these crazy features in order to be able to run that one demo. So I guess, yeah, the last thing I want to talk about quickly is, how you get one. And so I'll tell you how I do it. So this is what the EconoPet looks like when it comes from JLC PCB. They're a manufacturer in China. You go to their website, you upload a set of manufacturing files, and this is what they send you back in the mail. So it's a PCB, and you can see all of the surface mount components are already installed by their pick and place robots, which is it's really cool. The through-hole components are unpopulated, and so you then go and order a set of parts from Mouser. You can get them from different distributors, but Mouser distributes the Western Design Center chips that Frank was talking about earlier. They're still manufacturing the 6502 and so on. So as you get those and you do the through-hole soldering, and that's what you end up after the board's fully populated. A lot of these components are not components, but headers are optional and don't yet currently have a use. They're for future expansion. It'd be easy to add them later if you want to skip them for now. So that's what I do. This was a project where, I was hoping this would work is that there, while there's low demand for it, I could build, maybe one a month and sell it for the cost of parts to, people who need to repair a pet or just interested. Since, it turns out I finished this about just in time for the United States to get into a trade war with China and institute a bunch of tariffs. It's now no longer such an economical pet if I'm the one who builds them. And so I was just going to offer if there's anyone outside the US who wanted to assemble these for others, I'd be happy to consult and walk you through the process. I guess if people really want me to, I'd also be willing to do a batch, but I'd feel bad passing on the cost of the tariffs to others. So anyways, that's the EconoPet project. That's where it currently is. I'm happy to answer questions if there are any, or I can give the time back. Thank you for having me.
Well, great. Many thanks to you, Daniel. Maybe I start with one question, because a few years ago you came here to present the homebrew pet, and I guess this one is an evolution of this homebrew pet. Did you document that somewhere? Like, do you have like versioning of so that if someone is interested in going into the whole process of the evolution, is that documented somewhere, or is it just like on this side there?
So it's, everything's been checked into GitHub. And so if you wanted to, you could go through GitHub history. It turns out that when I presented to you last time, I was like, oh, I need to make this stuff public. And so I created one GitHub project, which is, all the way up to exactly where I presented to you. Then there's a new one called the EconoPet that starts from there and then continues on. And so you do have those 2 points in time. But
so it's really the evolution of what you had presented last time. So it's...
Yeah, that's right.
Okay, great. There is a question in the chat, but I think you answer it from Inbar. Is this only open source, build your own, or also purchasable? I think you explained how and where to have it built. Inbar, if that doesn't fully answer your question, don't hesitate to just unmute and follow it. The other question I had is about the keyboard, because the keyboard that you show there, is that one that you purchased as such or that you built yourself? Because if I understood correctly, you can just pick one key and then you activate the graphics, also the PET key or something like that? Or?
Oh, yeah. So, yeah, this is a purchased keyboard. There's nothing special about it. The thing where we're talking about toggling the between graphics and business, it doesn't change anything when you're using this keyboard. Actually, maybe the best way to do is show you. So if I type ASDF like this, it types ASDF here because it matches. These are both expecting. I think it's business right now. And so if I toggle the graphics and I type ASDF, you'll see I'm starting to get weird garbage and the cursor's moving around.
Yeah.
That's because when I'm pressing a key here, it's getting translated to the other PET keyboard matrix and being sent.
Okay. So you can switch to the type of mapping of the keys between. Okay.
I have a small questions regards the orders. So could you tell me what is kind of the cost of producing one board? I do believe, just like at the lower how you can get like ISA 5 in a JL PCB. I do believe, yeah. So what is the cost? Just I'm trying to see how much just like the additional just like a tax we have to pay now.
Yeah. So I did an order right before tariffs went into effect of 5 boards, and the amortized cost at that time was $130 for just the parts. Everything fluctuates. It could be $145 one day, and you never know what it's going to be, but around there. I don't know what it would be of tariffs. Like I've heard it'll add like 70% to the JLCB PCB order or 100%. This is based on people in their Reddit channel. Was it printed circuit boards where they're discussing the costs? It turns out it seems like it's still the cheapest option to have something done in low volume with SMT. But yeah, that's kind of what I'm expecting. I'm expecting something around 70% increase in cost with tariffs.
Okay, I ordered actually. It was like I was surprised. It was 20%. Up.
Okay. Yeah.
Just like for the small boards, and also fully assembled. It wasn't bad. Just okay. So yeah, still it's economic. So and really thank you. And it's just like I never had like a pad because I didn't have like so much space. But right now, just like I'm seeing, myself, just like I'm getting one. The form factor is great.
Yeah. I don't know if anyone else here happens to have more up-to-date information on the tariff situation. Like I haven't actually gone through the process of trying to stage an order to see what it would be. I've been just deterred by what other people have said.
Great. I don't see any more questions, but again, if there are any, we can just post them in the chat. Many thanks again, Daniel. Stopping the
Thank you.
And then I invite Yanis to just unmute and start sharing then his screen or video.
Hey, I'm here. Hi.
Perfect.
Thanks for having me. I'm a little bit shy on this because I've never done this one before. So I'm pretty sure that my project might sound like, most of you are probably much more seasoned than me. I mean, I'm actually this hobby or in this idea for the past 5 years. It started as a what if scenario.
Sorry to interrupt. Just before you start, do
Yes.
you have something to screen? Do you have something to share on the screen?
Yes, I have.
Okay. Just so that you know, then I'm starting the recording
yes,
now.
start doing this, yes. So let me introduce myself. So I'm Yanis. I live in Scotland. I'm a software engineer. And for the past more or less 30 years, what I've been doing on and off is asset tracking. And in particular vessel tracking in the North Sea. And that gave me an idea 5 years ago during the COVID pandemic. Can I bring this? Now I will start. Can I bring this? Try to share the screen. Sorry, it's coming. So the idea was, if I can bring this, oh, come on now, why? I've noticed that my browser is not working. Ah, it's working. So my idea was, can I bring this, which is marine traffic, as most of you know, into a Commodore machine? Can I track the vessels real time and see them? I always wanted to play with data coming, and back in 1987 when I got my Commodore, there was no internet and there was no data flow, so programs were pretty static. From the other hand side, I was also thinking that everybody's doing games. Let's try to make an application that can actually do something. So I spent 5 years learning machine language because I had never actually done anything on this. I was mostly a C# Java guy. And 5 years later, I managed to have this. So what is this? This is essentially the marine traffic running on a Commodore 128. And the technology behind it is actually homebrew. I mean, the code is actually on GitLab. So I found a SwiftLink library on the internet, load it low in memory where the VIC screen is, because in VDC you don't need it. Pumping the data through the NMI of the C128, filling a buffer with the data. Then the IRQ keeps on draining this buffer. The buffer is running a decoder, so I'm essentially fully decoding the message as it comes. These are not pre-decoded messages. This is actually the full thing. I'll show you exactly how it's done. And for every vessel that I managed to discover through the discovery, I put it in a registry. And you can see here, for example, that the codes, the color codes are correctly because they correspond to the type of the vessel. You can have up to 256 soft sprites here, and they're moving. I mean, this guy is moving out. If you are lucky, you will see him moving out of the port of Aberdeen. And green is, red is tags, very red is tankers, yellow are service speed crafts. This one, I don't know, we'll find out. Of course, the problem that I had when I started creating this one is that how you can actually show the data to the user in a friendly way. And then I bump across a project by Martin. He was supposed to be here, who kindly lent me his QR code libraries. So now, for example, you can go with your mouse to any vessel that you like. If you right-click on the mouse, don't let me down. If you right-click to the mouse, come on, right-click to the mouse. Sorry, the mouse is not very cooperative. Here it is. If you right-click on the mouse, it will go to the vessel registry, go and get the information about the vessel, and will produce the QR code. And if you have a mobile phone, you can actually scan the QR code, and you will see that it will get you to the marine traffic website with exactly the same information for the vessel. I can leave it for a few minutes there for everybody who wants to play with this. So you can see what is the ID of the vessel. You can see the latitude, the longitude, the speed, the course, heading, name, call sign, destination, the IMO number. That type, 99, is the one that gives the color to the vessel. This one doesn't have any code. It's a generic thing. and how deep in the sea it is sitting, 3.5 meters. So why would you like to do this one? Because you can, and because I wanted actually to create some kind of software for the Commodore 128 that looked a little bit more professional or something. Recently, I even managed to let me try to get there. Oh, recently, I managed to implement a file system on it. So now you can also get the actual data. As you can see here, I'm logging every single message that's coming back, about 540 kilobytes. And I can show you how the messages look like as they are coming raw from the transponder. So, got a very, very small presentation of how do I did it. Oh, run, please run. So, small presentation of how do I did it and what's the technology behind it. So I am using Basic 8. I don't know how many of you know it. Not for everything, just for the rendering, because it has all the VDC libraries and you can actually render things in the VDC, even in 3D. And I didn't have time to learn VDC. I wanted actually to focus on the machine language. So Basic 8, because it offers VDC. As I said, my plan is I will use its features to turn it into a 3D application. So that means that even it will be slow, you will be able to be on a first person and move yourself in one of those vessels and see the rest around. I've got pretty a lot of, still resources to do this one. I also wanted to play around with the misunderstood wait command of the Basic, because by using this one heavily, I've managed to make Basic sleep most of the time doing nothing, while the machine language is doing all the heavy lift of the decoding. And then what the machine language is doing finally is setting one of the flags to what the Basic is waiting, and Basic is just waking up to actually do one of those things. And one of the things that it's mostly doing is that, great, you have a message, it jumps here, that's all the line of the code that is doing, and it goes essentially with a double buffering and goes and draws and redraws the vessels, and that's happening quite quickly. And that's why, for example, you can see here that, we've got about 49 vessels watching. I've gone up to 250, and they all can be moving, and they are all up to date. Actually, sometimes this one is much more up to date. Oops. Actually, this sometimes is much more up to date than this one, because he's receiving a lot of data from all over the world, and he's updating every, 5-10 minutes, while this one is actually quite snappy. You can see these things moving. The other interesting thing is that you see Commodore is starting at 1:00 a.m., but because the so-called days messages type 4, they carry the time, I synchronize the real-time clock of the Commodore once it comes, so you can see actually what is the exact time on the machine once the software starts. Currently I think this one is running since morning, and I have decoded about 70,000 messages, and it's counting. And there is a lot of memory still yet left to continue. Memory-wise, it's a little bit. It might be a little bit amateurish. That's how I have started it. So I've got this serial comms library in the low 400 because it needs to talk to the Swift registers. Then there are where the tape is, the IRQ and the NMI bridge is sitting. Also to be able actually to use the kernel if needed. The ring buffer of the Swift link is sitting there where usually the buffer of the serial port is sitting. And then higher up in bank 0 from, I've got at 7,000 the vessels, the registry with where I save everything in memory, and the code is between 8,000 and AA70, and then I've got a 0 page only for the decoder, and then the basic is from there on up. And looks like that it's working, and I'm quite happy for this. I don't know if you find it exciting, but I mean, my future plan is actually to turn this one into a flight radar, because it's the same idea, the same kind of data. I mean, it's actually lighter in flight radar because things are not encoded, while this guy here has to decode things. And that's it. I don't know if you find it exciting, but I find it. Any questions?
Many thanks, Daniel. I think it's pretty much exciting, actually. Yeah, I met someone who was preparing something a bit similar with using weather forecast data, so mapping it. I don't know if there are questions from the attendees. Maybe I will start shooting one, because I see. So now you're using Vice, but so are you using expansion RAM for that, or how would that work if you have, for example, because now you have 49 vessels there, but are you also buffering the whole information of each vessel? How would it work if you have, like, if you're...
Well, I'll tell you, basic 8 needs the RAU extension just for the double buffering.
Okay.
Okay, but the software doesn't need double buffering. I can actually share the code here. So this is where everything is starting, and essentially as I said, up in the 7,000 area, which is in bank 0 there, I've got the structure for the registry of the vessels. So up to 250 vessels, I've got 200 now. It's 15 bytes per descriptor, so that's well within bank 0. And then in bank 1, I save the actual positional information and all the things that are coming, and I'm updating them. I'm not keeping them forever. I'm just overwriting things. So actually, the stock Commodore 128 is more than enough to run it. The only reason that I'm using the expansion is because BASIC needs it in order to do the buffering of the screen and be able actually to switch between one and the other and give the illusion of the motion. Mm-hmm. Plus the ultimate cartridge, because I can save their things, well, not faster, but than actually trying to save in a disk. I was trying to show you this file. If can you see my Windows PC now?
Yeah, kind of. I don't know if that's the sun or
okay,
big
fine.
ball.
Well, yeah, so I can show you this one. That's okay. So if I take this one, copy. I mean, this is the file that I'm actually saving. This is the file that I'm saving, and this one is being saved real time also from the library. So it has the ability actually to save quite a lot. And you can see here as the raw data comes inside the computer and how they are encoded.
Okay.
This is actually the real data, and I capture them to the file on the Commodore. It seems to be coping with no problem. I mean, ideally, I would like actually to try to do this one faster way. I don't know, maybe I don't know if I'm actually using the correct idea. This is just kernel calls to the right and the setlfs kernel calls, but I think it might become faster if you do something like burst mode or something. I'm not really sure, but you know, I mean, it has been loading things happily all day long actually, and it has not missed a bit. And yeah, of course, the idea is that there are going to be 3 more files created. One is going to be the actual registry with the save data. So when you restart it, you can actually start from where you were.
Oh, nice.
I don't know if there are any questions or if you find it interesting, but
I find it interesting, definitely. Yeah. I don't know if there are other questions from the. I see an applause. That's a reaction. Any other questions?
I have one question.
sure.
So have you open sourced that, or have you planned for Commodore 64? I know that you're using probably RGB graphic interface from Commodore 128, but this seems to be also feasible for Commodore 64.
It's not impossible, as I said, as long, I mean, I'll tell you what I was thinking, and that's what I'm trying to do the last few days. If I manage to even optimize even more the file libraries, and I manage actually to write faster to the disk drive, then your memory issues just goes out of the window. Because at present, as I told you, I'm only keeping 15 bytes times 200 in an area as a registry. And the good thing with the Commodore 128 is that I can actually have a pointer there to the bank 1 where all the other data are. But I don't need in this scenario any of those things. I mean, I can have the pointers to point to records in files, especially for the static data, which are the longest and they never change. You can save them on the hard disk. So you don't even need to keep them in another piece of memory. So I think it kind of going to be possible for C64, and I think of porting it. Maybe you might need some kind of RAM expansion unit to make some swapping in memory.
I think just like at least today, most of the people are supposed to have like a real memory expansion, today. So it's easy to program for it. So
yeah,
okay.
it's not. I don't think that's a problem. And also, I have tested the SwiftLink driver, and works fine with the C64. No problems. You can go up to 57,600. What is the thing, and it works fine. What I have ordered though, I have ordered a weak 64 now, because the idea is that weak 64 is this interface that goes to the user port, not to the expansion. No, sorry, to the expansion port, not where the old RS-232 was, and that's supposed to give you internet access through its own layer. So the idea is that in the next version, I will actually poke the marine traffic website and I will import the PNG, decode it, and you will see the picture of the vessel. Or if it is a marine, or if it's going to be a flight radar, I will poke the flight radar and I will bring the PNG of the airplane and I will actually convert it to. I mean, it's going to be slow, but for a small size picture, it worth to be done, and then you can decode it. Yeah, that's the idea. Are there any other things in the pipeline for me? I was thinking. Yeah, as I said, yeah, implement. Yeah, use the week, enable the 3D mode. Yes, because the basic 8 allows you to 3D, well, some kind of rudimentary 3D. I was thinking that the other thing is that you can actually move yourself as a first person in a 3D environment and stay here and see the rest of the vessels. I don't know how much motion I will achieve like this, but it will be possible to see. And yeah, I mean, port it in C64 is a good idea.
Very interesting. Then you have new projects to come and present
Yes,
in a
yes.
few months,
I
right?
think maybe the next one will be to try to do the pictures. You know, import the PNGs and show them. Saying this, I need to say a few thank you. Thank you to, I mean, Martin is not here. Martin Goodwell, who's got a YouTube channel, who actually did the QR code, and he kindly lent me the code to do this one. And Arthur, who actually wrote the CBM PRG studio and where I've done most of the work there. And that's all about me.
Great. Many thanks again, Yanis. I don't see any more questions, so I will just stop the recording.
Thank you very much.
And that leads us to the end of at least to the agenda here. One thing I wanted to just wanted to say a couple of things before we close. Of course, the next meeting is expected to March 26th. That will be announced on the website, but you can already expect something. And for the people attending also the live, by the way, the live on Facebook seems to be solved in the meantime. So don't hesitate to suggest your let's say topics for the next meeting. Then there is another event that is absolutely not linked here to Commodore Users Europe, but still I think it's an interesting one. It's a huge free and open source developer meeting that is happening every year for more than 20 years in Brussels, Belgium, with more than 8,000 people attending. So physically it's a presential meeting. And there is every year there is a retro computing dev room, so developers room, that will be active also this year on the Sunday, first weekend of February. So you can go to fosdem.org and check that there. And if you pass by Brussels, then first of all, I will be actually hosting this retro computing dev room, so you can see me there. And if time does not allow, but you're still visiting, just let me know and we can meet at some point. So of course I cannot close before thanking again all the presenters today, also the attendees. But as I say every time, if there is nobody presenting their work, then there is no event, of course. So many thanks again to all of you. And we're going to close now, so see you next time in March. Okay, thanks to all.
Thank you very much.
End of day or end of
Thank you so much.
evening. Yeah, thank you.
Thank you.
Thank you.